Okay, so we are reviewing. Let's move this thing over here like this. Okay, we're reviewing for the test on Chapter 7, right? So Chapter 7 test. Just say it's a review. Alright, so here's what's on the test. Number 1. It's going to be, if you look at that worksheet that I gave you the other day, that Form 2C, you should still have it. It's kind of like number 1 on that one. It's a word problem. But it's a very simple word problem. It's not that difficult. It's a word problem that just, you just find the ratio. Okay, they'll give you a couple of things. I'm not going to give you an exact example. But if you look on that worksheet, that Form 2C number 1 on that worksheet, it looks kind of like that. Find the ratio, and then make sure you always reduce. And it even says on the test, it says reduce the fraction. So it might say something like the ratio of the, or there's like 5 boys in the class and 10 girls. What's the ratio of boys to girls or something like that, okay? 5 over 10, 1 to 2, that kind of stuff. All right, it's pretty basic, pretty straightforward. You might have even had one on quiz, I think. Didn't we have one like that on quiz? Where I gave you something like that, yeah. Okay. 2 and 3 are, it's just cross multiply. They give you a proportion or 2 fractions, right? Something over something. And then what do? You cross multiply and solve for x. Again, on this review, I'm just giving you very general review things here. With me so far? All right. 4 and 5 are kind of the same. Let's see. Did they give you one like that? I don't think they gave you one like that on the practice test or the worksheet review thing I gave you. But if you remember this, they give you like, I'll just make up, this is off the top of my head. I don't know if the numbers are going to come out nice and pretty. They probably won't. Remember we said like the perimeter of a triangle. Remember this? Like the perimeter of a triangle is, I don't know, 30 inches. And the ratio of the 3 sides are like 2 to 3, I don't know, to 4. Do you remember that kind of thing? And you got to find the individual sides. What are all 3 sides of the triangle? We had that on a quiz, so go back and look at one of your quizzes. We had 2 quizzes on this chapter. One of the quizzes had something like that on here. Again, I don't know if this is going to come out nice and pretty, but what would you do for something like this? Well, add what though? 2 plus 3 plus 4, or what? What do we do with that? Remember, this is not the exact sides of the triangle. 2x, right. You would go 2x plus what? 3x plus 4x equals what? What do they all add up to? Yeah, to 30. Okay? Does it make sense? So I tell you what, let's just make this so it does come out pretty. If we make that 45, that should. Doesn't really make any difference. But it's kind of nice if it comes out nice. So what's that? 5 and 4 is what? 9x equals 45. Divide both sides by 9. X is 5. Is that my answer though? X is 5? No, what are they asking for? They're asking for the lengths of the sides of the triangle. So what do I do? Fill it in, right. This is one length of the side, that's another length, and that's another length. So I would go 2 times 5, which is 10. That's one answer. Then I would do what? 3 times 5, and so one side would be 15, and then you would do 4 times 5, and that's what? 20. Now they should add up to what? 45, do they? Yep. 20 and 15, that's 35, plus 10 is 45, and it does work. So what is your answer? It's this stuff right there. There's 2 problems like that, 4 and 5. One of them will give you perimeter. I'll give you a huge hint here on this one. One of the other ones, I forget if it's 4 or 5, so it's right in front of me. This is actually like number 5, where it says perimeter. Number 4 is kind of the same deal, but it says instead of 3 sides of a triangle, they give you 3 angles. So what do 3 angles of a triangle always add up to be? Doesn't matter what kind of triangle. 180, 180. Okay, that's definitely something you need to know. All right, so the three angles add up to 180. So I don't know. Let's just say the rate. I'm just making this up again. Let's say the ratio is 2 to 3 to 4 again. All right. But they don't tell you the perimeter because they're doing angles this time. Do they even have to tell you what all the angles add up to be? No, because you know. What do the angles add up to be? 180. So what are we going to do? We're going to go 2x plus 3x plus 4x equals what? 180. And then you can do the rest of it. I'm not going to do the rest of it for you. Does that make sense? So one, they'll give you a perimeter, so you know to add them up and set them equal to the perimeter right here. And then one of them, they say they're angles. Now, I just made these numbers up, these ratios up off the top of my head. There'll be different numbers, but that's how you do it. Everybody with me on that? Sure? Questions? Okay. Change colors. Yellow. All right, so number 6. Number 6 is where they give you 2 triangles. Again, I'm being very general on this. I'm not giving you, except for that one, I kind of did give you specific numbers. On this one, I'm really not going to. So you've got one triangle here, you got one right here, and let's say this is like that. Now, they may not look perfectly next to each other like this. They may like twist it around. Oops. Try something. They may like twist it around like this, right? And then what are they going to give you? They'll give you something here, and they'll give you something here. I don't know. I'm not even going to attempt put numbers in here. But what are we going to do? Like if they said this, that ABC, and which one would be A? This would be the C, wouldn't it? And this would be, yeah, that one. Okay, so this would be DEF like this, right? So they might tell you something like this, that triangle ABC is similar to triangle DEF. Now, how do you know which angles are equal to each other? This thing is really important. Again, don't blow this thing off, okay? Understand. Okay, so A is equal to what over here? To D. And how do you know that? Just because it looks like it? No, because they tell you that A is first and the D is first. What about the B? B is equal to E, right there, and then of course the C is equal to F. And how do you know which sides are in proportion? I'll tell you what, let's just put a bunch of letters here. We'll go X, Y, Z, we'll go P, Q, R. Okay? So how do you know what's your proportion? What would you compare? You compare X to what over here? Said PQR. To Q. Right. Okay. Right? This is side X, would you agree? And this is side Q. How do you know that they go together? I don't see an X or a Q up here. How do you know? Because it's opposite what? Well, it's opposite the angle with 3 arcs, right? And what's opposite the angle of 3 arcs over here? Q. So the X and the Q go together. Agreed? What else goes together? The Y and the what? How do you know? Because the Y is opposite the 2 arcs. What's opposite the 2 arcs over here? The P. So Y and the P go together. See that? And then the Z corresponds. I say go with, but the technical term is corresponds to what? This is opposite the 1 arc. What's opposite the 1 arc over here? The R. Now, of course, you're going to have numbers in here. You'll have X's. You might have like an X plus 3 or a 2X minus 1 or something like that. Okay, they won't just be just individual letters like this. And there'll be numbers. And if you want to solve, what would you do? Cross multiply. Okay, and then you can solve for whatever they ask you to solve for. Does that make sense? This is pretty much what we've been doing the whole chapter, isn't it? That kind of stuff, comparing one side to the other, cross multiplying, getting an answer. Right?
Once you cross multiply the first one with the third.
Well, you don't. All you need is 2. I just showed you all the things that are in proportion, because sometimes they don't even give you that third one at all. Okay, so you just take the 2 that you can use, right, that they give you, cross multiply, solve for X or whatever they ask you to solve for, and then you're good to go.
So the X does not actually represent a number.
Well, X does, even when
No,
it's an
yeah,
X,
but
it represents a number.
But like Z and Y are like
These could all be numbers, or they could be, like I said, they could be like 3x minus 2, or 5x plus 1, or something like that. Or they could be numbers. This could be 13. This could be 7. You know, right? I'm just showing you very generally. Okay, very general. This is not a specific example. This is just a general example. Okay, number 7. Let's see. I want to spell this one. You know, it's pretty much like this, except they don't draw the pictures for you. Right? They'll say, like, triangle FGH is similar to triangle RST. I'm trying to use different letters. Alright, so they'll tell you this, and they'll tell you what some of these sides are equal to. They might say, like, side FG is equal to 5, and then side RS is equal to 10, and all that kind of thing. Right? So they don't draw the picture. They'll just give you the information, but it's pretty much the same as this. You set up your proportions, you cross multiply, and you solve for whatever they ask you to solve for. But they just set it up differently for you. Okay, this one, they drew the pictures, they tell you all that kind of stuff. Here, they still tell you which triangles are similar to each other. They just don't draw it out for you. And they don't put the numbers right by the sides. They do it like this. So it's kind of the same problem. It's just, you know, some people have more difficulty with this because they can't see it. So what do you think I would suggest that you do? I would draw the triangles, right? You don't know what kind of triangle or what it looks like. It doesn't matter, right? Just draw some triangle FGH and make the other one look similar to it, right? Okay, just make it look a little smaller or bigger. And then plug all the numbers in. That would be my suggestion to you, okay, is that you draw the stuff out. You okay with that? Yeah. All right, let's keep going. Number 8 and 9 is this kind of thing. Again, I'm not going to put numbers in here. I'm just going to talk very generally about this. You have a triangle, and then you're connecting from here to here, and they tell you that this and this are parallel to each other. Remember this? And what do we know? Watch this. I'll put A, B, C, D. Do you remember what proportions we can set up if we have a situation like this? We can compare, what, A to, you could go A to C, but if you go A to C, what do you have to do down here? You got to go B to D. Now again, what are these going to be right here on the test? They're going to be numbers, right? You might have one of them being a variable, right? You may even have two of them being a variable, like one of them being like x plus 1, the other one, you know, 3x minus 2 or something like that. But the others would be numbers, actual numbers. But you need to know how to compare them. So you compare A to C equals B to D. What if you didn't want to go A to C? What's another option? Or you could go A to B. All right? If you like A to B better, that's fine. If you go A to B, what are you going to have to do over here? C to D. Because if you cross multiply, look, you're going to get the exact same thing, aren't you? If you cross multiply, what do you get here? You get AD equals BC. What do you get here when you cross multiply? You get AD equals BC. It's the same thing, isn't it? All right. What's the one way that you can't set it up? A to D. You can't compare A to D. Don't do it. All right. Because what is this? This is the top left. This D is the bottom right. Do they have anything in common? No. So only the ones that have something in common. Look, this is the top left. This is the top right. Do they have something in common? Yeah, they're both on the top. Look at this one, A to B. This is the top left. This is the bottom left. Do they have something in common? Yes, they're both on the left. But does A and D have anything in common? Nope. This is top left. This is bottom right. They have nothing in common. You cannot compare A to D. Is that making sense? Let me know if it doesn't.
We go back to the
We good? Okay. Let's see. 10 and 11. 10 and 11. A triangle looks like this, or two triangles. Again, you've seen this before. Nothing new. Then one kind of was like this, and one was like that. Remember seeing that picture before? Yeah. And they tell you that that and that are parallel. Let's put some letters in here again. Okay, we'll do the same thing. We'll go A, B, C, D, E, F. Alright? First of all, are they similar triangles? Yeah, they are, because all you need are two angles. So you got parallel lines cut by transversal. This angle and this angle are equal. You got these vertical angles are equal, and you got these up here are equal. Okay? So I showed all three. You only have to show two, but anyway, what if I wanted to solve for? Oops, I got this. What if I just wanted to solve for A? How can I set this up? I can compare A to what? To B. How do I know A and B go together? Because they're opposite the two arcs. You see it? This has two arcs. A is opposite the equal angles. So A and B go together. Alright, let's set up another ratio. What else goes together? C and D. How do you know C and D go together? Because C is opposite one arc and D is opposite one arc. Alright, so C and D go together. And what else goes together? The E and the F go together. Okay? Now, you're not going to necessarily use all three, are you? You're going to pick the two that they give you, right? Because they may leave something out. They may leave one of these sides out. Let's say they don't give you E and F. Then you wouldn't use this, would you? Then you would just use this thing. If you wanted to solve for A, what do? Cross multiply. And again, what are the A, B, C, and D going to be on the test? They're going to be numbers. They're just going to be numbers on the test. One of them is going to be a variable. Again, you could have one not just being an x. You could have one being like an x plus 3 or a 2x minus 1 or something like that. All right? But you still stick them in here. You cross multiply, do your algebra. I'm not here to teach you the algebra part. Okay? I'm here to help you set it up, and you should be able to do the algebra on your own. Is this helping at all? Okay. 12 and 13 deal with mid-segment. Do you remember that name? Mid-segment? Let's write that down. Mid-segment. Okay, the mid-segment of a triangle. So let's draw a triangle. Just like that. And what is the mid-segment of a triangle? Well, what does the word mid mean to you? The middle. Or what are we going to do to that side? Find the midpoint, right? Find the midpoint. And let's find the midpoint of this one. Would be about right there. And let's find the midpoint of this one. That would be there. And if I connected the midpoints, any two of them, it doesn't matter which one, that would be considered a mid-segment, wouldn't it? Let's just connect that one right there. So what do we know about the mid-segment? Well, it's parallel to its opposite side, okay? And we also know the length. So I'll just throw a number in. What if that was 10? What would this mid-segment be right here? It would be 5, exactly. So that's what we know about a mid-segment. Everybody with me on that? So if this is 10, this is 5. Of course, if they tell you this, you double it to get that. All right? So that's all I'm going to tell you. So 12 and 13 are about mid-segments.
What were you trying to find in this?
Like I said, they give you this, and you had to find this. Right? It may be that simple. It may be maybe a little bit more difficult, but the basic idea is there for mid-segments. That's 12 and 13. Let's move on. Let's see. Oh, 14, sorry. 14 is also mid-segment. Let's throw that in there. 12, 13, and 14. It's all mid-segment. Let's see what color I want to use. Let's use this green. Alright, this next thing like this. And they put a parallel line in here. Actually, no, we do this. Yeah, they don't really call this a mid-segment, but actually probably is. So watch, find the midpoint here, find the midpoint here, and then connect like that. And then they put some letters in here. Watch, this is A, B, C, and D. And watch what they do. They say that these two are equal, and these two right here are equal. They couldn't have made this any easier. Remember you did this on the quiz? Most of you got this right, so it's pretty good. I don't know, I'm just making this up. So let's say this side, instead of A and B, I think we can make something up, can't we? So let's say that's like 3x plus 2, and let's say that's like 11. We'll make it easy, okay? So what would you do? Do you have to set up a proportion for this? No, you don't, because what do they tell you about these two segments? They're equal to each other. So all you got to do is just set them equal to each other. All right, that's it. All right, some of you guys made it more complicated by trying to set up proportions. But if this side is equal to this side, and they tell you both of them, just set them equal and then solve for x. Like I said, most of you got it, or many of you, I think probably most, got it right on the quiz. 3x plus 2 equals 11. Subtract 2 from both sides. That's 9 divided by 3x is 3. Right? So that's the kind of stuff that they want you to do. So that would be number 15 and 16. Did I write that down? 15 and 16 look like that. And 17 and 18 kind of look like that too, except it's not a triangle. What do you think it is? Do you remember doing these problems? Yeah, parallel lines, exactly. Yeah, so. No, because they'll just ask you to solve for x. Because there wouldn't be much work if they asked you to solve for this segment right there, because you know they're equal. If this is already 11, you don't even have to think about it, and that's going to be 11. Would you agree? Okay. So the next part, 17 and 18, is probably even easier than the triangle part. It's pretty much the same. Parallel lines. Like this, and then they have another one that intersects them. Actually, you got two that intersect like that, right? And then we'll call that A and B and C and D. Now these purple ones are all parallel to each other. Again, this is really close to what we just did with the triangles when we set up our proportion. Okay, now no, actually, you know what? They make this easy. I don't know why they make this so easy. They actually do put that in the middle, right? And they say that this is equal to that. It's almost embarrassing they make this so easy. All right, so what do? If we know A and B? You just set them equal, right? I'm not going to bother putting numbers and letters in, all right? I think you already got the idea now, don't you? So you set these equal to each other, you set these equal to each other, and then you just solve for x, solve for y, whatever they ask you to solve for. Actually, 17, they actually ask you to solve for x, and then number 18, so it's like two separate problems. They say solve for y. So like your x's would be over here, your y's would be over here, just like the quiz, right? Remember this from the quiz, don't you? Yeah. Yep. Right? It's just like the quiz. So review your quiz. Okay, number 19. Let's write 19 right here. You got two similar triangles again. Something like this. And let me copy and paste that. Put it over here, just make it a little smaller. Like that. And they do this as well. They put that there, and they put that there, and you say that this is equal to this, so this is equal to this. Okay? They also tell you that this and this are equal, and this one and this one are equal. we only got 4 minutes left. Just hang on. So watch. We'll call this A, B, C, and D. You can go through and read the theorem if you want, but if you have a situation like this, where this hits the midpoint of this side, and this one also hits the midpoint of this side, which it does, and look, these two triangles are similar as well, aren't they? Because these have, there's one angle equal, there's a second angle equal, so they are similar. This hits a midpoint, this hits a midpoint. With all that said, what do you think our ratio is with our A, B, C, and D? I'm going to compare A to, what do you think? C, and what's that going to equal? B to D. It's pretty much normal, right? I mean, it just looks like the stuff we've been doing the whole entire chapter, right? Again, what are these going to be? They're going to be numbers and variables, okay? So you just do your ratio, you cross multiply, solve for whatever they ask you to solve for, and then you're good to go. Make sense? Any questions on that? Yeah, that's pretty straightforward stuff. And then you got number 20. Number 20 looks something like this. And this looks like that. That doesn't necessarily hit the midpoint, okay? So, but this angle and this angle are equal. This is a bisect. You bisect an angle. Again, you can look it up in the lesson to see what theorem it was and read the theorem for yourself. But it basically says this. If you have a triangle and you bisect one of the angles, right, it says that the segments are in proportion. So, or these two segments are in proportion to the two sides. So again, I'm going to put A, B, C, and D again. So we can do it several different ways. You could compare A to, what do you think? You can go A to C, but if you go A to C, you have to do what? B to D. Sorry we're using the same letters every single time, but it's the easiest letters I can think of, the first ones. Okay, so does that make sense? So if I can compare A to C and then B to D. Yeah, absolutely. If you didn't want to go A to C, you could compare the two sides to the two segments. Okay, so you could go A to B, and you could go C to D. Yeah, but if you go D to B, then you have to do what? C to A. You know, there's like 4 different ways you could compare those. All right, and that's your test. That's number 20, by the way. That's it. I'll give you a huge hint. I wasn't going to do this, but I'll give it to you. So we'll see if you actually listened today or wrote this down. I'm going to ask you to solve for y, but I won't tell you this little part right here, but I will tell you the whole thing. I'll tell you the whole thing. I'm just making this number up, 20. So how in the world would I do that? I could compare A to B, but then I have to compare this little segment to this big segment. What is this little segment right here? Is this 20? No, what is it? Which one's the bigger? I've done this on several occasions before, and I thought this would help, but I don't know, apparently it didn't. What if this was 15? What if that segment was 15? What would this little bit right here be? How'd you get it? You want 20 minus 15, okay? But I don't know it's 15. I just made that up, okay? What did I say it was originally? It was just y, right? When it was 15, you saw it right away, didn't you? You said, oh, 20 minus 15, that's 5. That's easy, right? What if it was 10? What if y was 10? You'd do what? 20 minus 10. What if it was 17? You'd do what? 20 minus 17. Well, we don't know it's any of those. We know it's y. So how do you figure out this little bit right here if it's y? Say 20 minus y, yeah. For some reason, we have this roadblock with letters and numbers. Remember, letters are numbers, aren't they? Okay, so when this is 15, that didn't bother you at all, did it? You went 20 minus 15 is 5, easy. Well, when I say it's y, then all of a sudden this wall comes up and we don't see it. But how would you figure this out? It's 20 minus whatever that segment is. That segment is y. This little segment is 20 minus y. So if I was going to do a ratio, Now, again, these would be numbers. A and B would be numbers, okay? So if I compared A to B, what would I compare down here? 20 minus Y to what? To Y. And then you would cross multiply. Again, A and B will be regular numbers. All right, look at that for timing. Pretty good, huh? All right, please be ready for it. I'm collecting two things tomorrow. I'm collecting the worksheet and I'm collecting the practice test. So I have both of those ready to turn in tomorrow. What's that? The Chapter 7 worksheet, the Form 2C, bye-bye, and then the Form 2C.